Okay, 6.1, vectors in the plane. Okay, so what you're going to learn about is two-dimensional vectors. We'll do some vector operations like addition, multiplication. We'll look at unit vectors. We'll do direction, and we'll apply these because there is some application, obviously, some real-world application. Otherwise, we wouldn't even be talking about vectors. Those of you that have taken physics know this already. You can use vectors to represent velocity, acceleration, all kinds of different things, or the effective wind on an airplane's path, or displacement, all kinds of areas we can use vectors to help us simplify and make sense of things. All right, so what a vector is it's a directed line segment. So it is basically a little ray, but not a ray because a ray goes on forever in one direction. It's a directed line segment that goes from one point to the other, like from 0, 0 to AB. So basically this vector goes over A and up B. All right, so we write it AB with the vector brackets like that. We can then look at the magnitude and things like that. And what's important is we know the magnitude and the angle because that's what's important about vectors. The magnitude and the direction. That's important. Magnitude and direction are the two things that we want to remember when it comes to vectors. It doesn't matter where you place this vector. What matters is it has the same magnitude, which is represented by the length, and it has the same angle, which is represented by this theta here from horizontal. All right, vectors have an initial point, terminal point. Like this is the initial point 0, 0, the terminal point's 3, 4. These vectors are equivalent here. Both these vectors go over 3 up 4, as you'll see, over 3 up 4. So it doesn't matter where you place them. They have the same length and same direction. Therefore, they're equivalent. Okay, we're going to use the head minus tail rule, which is right here. We subtract the x-coordinates and the y-coordinates in order to, which I'll show you an example in a second, in order to find the component form of a vector. With magnitude, what we're going to do is the Pythagorean theorem, and I'll show you that as well. This is how we use or talk about magnitude. We use these little brackets like the absolute value brackets. But it means basically to find the distance of the vector when it's placed at the origin. So if you place the vector at the origin, this is A and this is B, or this distance there, they call it x2 minus x1, and this distance would be y2 minus y1. You subtract the y-coordinates to get this, subtract the x-coordinates to get this, and do the Pythagorean theorem, and that gives you the magnitude, which is the length of the hypotenuse. So here's an example then. We have this vector PQ, which is represented by connecting these 2 points, 3, negative 4. Here's point P. And it goes to Q, which is over 5 up 2. Okay, so our vector goes from P to Q like this. So if we use the head minus tail rule, what we find is we go over 2 and up 6, getting from P to Q. All right, so if we want to find the magnitude of this vector PQ, now here's vector PQ right here. If we want to find the magnitude of it, we just do the Pythagorean theorem right here. So it'd be 2 squared plus 6 squared equals C squared, which gives us C equals the square root of 36, so it'd be square root of 40. Okay, next is vector addition and scalar multiplication. When we add vectors together, it's really simple. We're going to add the x components and add the y components, which is what the book says here. And when we can also do the product of scalar, which is just a number. When we multiply a number, we basically just distribute it so that that number gets multiplied by both the x and the y coordinates. So let me show you an example of that. Let's take 3 times vector u, which vector u, so we're doing this right here. Vector u is 2, negative 1. We're going to add it with vector v, which is 5, 3. So when you do this, I'm going to distribute the scalar first. That gives me 6, negative 3. And I'm going to add it with this vector 5, 3. When you add vectors, you just add the x's and add the y's, so you get 11, 0 as our final answer for this right here. Okay, finding unit vectors now, what we're going to do is, a unit vector has length 1, and that's what this says. It's just a vector that has magnitude of 1. We can do that by taking the original vector and dividing it by its magnitude. All right, so let me show you an example of that. To find a unit vector that's in the direction of 2, negative 3, I'll even try to graph this for you a little bit. But 2, negative 3 is right here. Let's find the magnitude of this by doing the Pythagorean theorem. So it'd be 2 squared plus negative 3 squared equals c squared. So that's the square root of 13. All right, and all we have to do is basically just divide the square root of 13 by the x and the y coordinate, and that gives us our new vector, 2 divided by the square root of 13, comma, negative 3 over the square root of 13 is our unit vector that's in the direction of this. So if we were to actually graph this vector right here, it'd actually be this vector right there. Really small, goes in the exact same direction. Here's the x and y components, but it is a unit vector. So if you do the Pythagorean theorem on these x and y coordinates for this little black triangle right there, you'd find out the hypotenuse was 1. Okay, we're going to use I and j quite a bit in the homework, so you need to be familiar with what those are. I is the unit vector along the x-axis, and j is the unit vector along the y-axis. You can see how we can represent these differences. Let me just give you an example. Let's say that my vector is 3, 2. What I can do is make that 3, 0, just like they're doing here, plus 0, 2, right? Because when you add vectors, you just add the x and y components. And then I can pull out the 3 and make this 1, 0. And over here I can pull out the 2 and make this 0, 1. And what that means is this is 3i plus 2j. So you can rewrite vectors in terms of I and j in a different form. And it's basically this, you take this number 3 and put it in front of the I, and take the number 2 and put it in front of the j. There's another quick way to just go from here to here and write vectors in ij form. Okay, let's try an example of finding components of a vector. So if we have a direction angle of 120, 120 brings us over here, that's 60 degrees shy of 180, so I'm going to make a reference triangle right here. So I'm going to draw this 60 degree line, and the magnitude's 8. So to finish off my reference triangle, I'm looking at this triangle right here. It wants the components, so what it's looking for is x and y. Now this is on our unit circle, you might remember. We have relationships for this, so if this is a 60 degree angle, and I didn't draw this very well, but this would be the small leg. This would then be twice that, and this would be then x times the square root of 3, if you remember those relationships. So that means that x is 4, which makes this 4 square root of 3. So if I were to give my vector ordered pair, I'd say back 4 and up 4 square root of 3 in vector ordered pair form. Obviously, you need to be able to go back the other direction as well and find the magnitude and direction of a vector. So I'll just do vector u here, which is right here. To find the magnitude, once again, we use the Pythagorean theorem. So it'll be negative 2 squared plus 3 squared equals c squared. This gives us 4 plus 9 equals c squared. Therefore, c equals the square root of 13 is our magnitude. Now our direction, if this is 3 and this is 2, would be tangent of theta. I'll call this theta inside here. Equals opposite over adjacent. And so I can do inverse tangent of 3 over 2. And that gives me 56.3 about degrees. And now, if I want to represent that angle, you know, there's different ways to do it, but the best way to do it is do 180 minus that angle, and give the angle actually as 123.69 degrees. That way you're talking about the positive angle from the x-axis. Now, obviously, you know, if this was north, south, west, and east, you could just say, you know, 56.3 north of west, because that's this rotation there. But typically what we do is we start with our 0 heading along the positive x-axis and we rotate counterclockwise, in which case this is the best way to give the magnitude and direction. Okay, and then the book gives one really, really good example that hopefully helps you understand where vectors come in really handy. Velocity can be represented with a vector because velocity has both magnitude and direction, whereas speed's just the magnitude, so speed's just a scalar. So keep that in mind, that there are some things like velocity, acceleration, displacement that you can talk about a magnitude and you can talk about an angle, a direction, whereas some things like speed or time, typically those just have a magnitude and therefore just a value that we associate with them. We call them scalars.